about the proof of Pythagorean theorem, okay? So you have a recording sheet of this, and then you also have a big map of this, correct? Okay. In the top corner of your sheet, it says, you probably already know that a squared plus b squared equals c squared. Right? Raise your hand if you already have seen that before. Okay. If you didn't, that's okay. But you know what? It's written on the math chart. It says Pythagorean theorem, a squared plus b squared equals c squared. Okay. But just like everything else on the math chart, that chart is only helpful if what? If you know what it means. Okay. If you don't know what it means, then it doesn't mean anything. Okay. So basically what we're going to do is we're going to go through a discovery here to figure out where this model came from. Okay? If you're at home watching this video, we're going to pause this right now since it doesn't make any sense with cheeses and you can't see us. But the next piece of it, when it comes back on, will help. Okay? Okay, so you filled in what went for square A. How many Cheez-Its did it take to fill up square A? 16, right? So yours with Cheez-It, which was way more fun than me just drawing it, looks something like this, okay? So down here it says, how many Cheez-Its long is leg A? Meaning, how long is it right here? 4. Fill that in on your notes page. What is the area of the square of leg A? 16. And you knew that again because it took 16 Cheez-Its, right? Okay. Now go ahead and do the same thing for B. Here we go. So how many Cheez-Its did it take, first of all, to fill in B? 9, right? It should look kind of like a tic-tac-toe board, yes? So how many Cheez-Its long is leg B? 3. And then how many, what's the area? 9. Okay, now pause here. And over here it says, how many Cheez-Its do you think will be needed to create the area that is of the square that's created by the hypotenuse? How many do we think that's going to be? The whole thing. And what makes you think 25? Because if you go back to the formula, well, we already did a squared and b squared, so it should equal this, but we're going to prove it. So now I want you to actually take the Cheez-Its from here and move them into that square and see if it's true. Okay, were we correct? Yes. If you took all the Cheez-Its from here and all the Cheez-Its from here and moved them, it would now take 25 of them to fill over here, which you actually did, okay? So now let's answer these questions. How many Cheez-Its? We already did that, we guessed it. Let's try it, we did it. So what happened? It filled in all 25, right? That's what we said was going to happen, and that's what actually did happen. Okay? What is the area of square C? 25. How many Cheez-Its long is the hypotenuse? 5. Right? And then it says, this model proves that the area of a square of square A combined with the area of square B is the same as the area of square C. So A was 16, B was 9, and then C was 25. So now, describe that relationship in your own words. Describe what? That's where that theorem comes from, that a squared plus b squared equals c squared. And guys, this works for any what? Right triangle. Right triangles are very, very common and specific, work in very specific ways that they're so special they get their own theorem, okay? Okay, now I have a little video that I want to show you guys. If you will please take the Cheez-Its and put them back in the baggies, because listen to me, excuse me, everyone is going to be touching these Cheez-Its all day long, including the people that just hear. On the first one, you should have had square A was 9, B was 16, and therefore C was 25. Triangle 2, you should have had 36 and 64, which is 100. And then hopefully you double check that again to make sure they actually did add up, right? I know these are slightly off, and that's my fault. 25 and 144 to get 169 for number 3. Yes? Okay. Down here, did you fill this in where it had the sum of the legs? So C squared equals 25. So let me ask you a question right here. Could I go ahead and solve for C? How would I get the value of C? I could. But if C squared is 25, what's the value of C?
Why?
How do you know?
Because you divide it by.
Yeah, because if you took the square root. So here, C squared is 100, so therefore C must be 10. And C squared is 169, so C must be 13. Y'all should know your perfect squares, okay? All right? On the back, number 4, you should have gotten 64 and 225, which then equals 289. Yes? So then C squared, C would be how much? And then on the last one, y'all should have gotten 81, 144, and 225, and then C would have had the value of what? 15. Okay? And then on the bottom right, we'll cover that up so that we're not looking at it. I want you to fill this in, okay? It says in a right triangle, the sum of the squares of the legs has a special relationship with the square of the hypotenuse. What is that relationship? So basically, you're writing in what did you basically learn. It says when the areas of the smaller squares are added up, their sum always equals the area of the square of the hypotenuse on the right triangle. Something like that. Okay? Now, on the next page. All right. It says to find the missing area and write it in the blank. Be careful because sometimes they're giving you the size, sometimes they're giving you the area. I only want you to do this page, not this one. We're skipping this one for now. So only this page, okay? If you don't finish it right now, which I think you probably will, you will finish it for homework, okay?